This is how people sees NVIDIA. A lot of hardwares starting with GPUs, CPUs, interconnect, NICs, starting from a single chips to multiple chips and to supercomputers and everything in between. We are typically known as a hardware company. Well, that's true, but we are not just a hardware company. We are something more than that. So we are a hardware company, which is the bottommost layer. We bake our own silicon. We create machines out of that. But these machines are very specialized machines. These machines are like one GPU can have 10,000 plus cores. Now one CPU has 64 cores, 64 cores working at a gigahertz frequency, while one GPU has 10,000 cores, 10,000 plus cores working as a megahertz frequency. So it's a chicken and ox story. So if you want to destroy an entire farm, rather than releasing one ox, you release a couple of chickens, right? So given a problem of machine learning or deep learning where you have large number of matrix multiplication taking place, CPU does this operation serially while GPU does this operation parallelly. So when given a problem size and 10,000 cores start working on top of that simultaneously, these cores provides you actually many X performance than a CPU. So but the story is not so simple. So when you have a hardware which is capable of running things, anybody can create a hardware. If you have a $10 billion in your account, you can go to any of the fabricator, you can create a GPU out of it. But the difficult part is software. Software that we have created for last 20 years. We start with a system software, CUDA, that understands basic programming model, how you write your program that executes on a 10,000 cores. Then comes interconnect. So how you connect your GPUs, how you create a larger machine out of that, okay, or a supercomputer out of that is capable of talking between node at a 600 Gbps, 900 Gbps or 1.8 Tbps, right? So that's when the system software comes into picture. You need to manage this cluster as well. That's where the base command comes into picture. And you need to do a lot of I/O operations between storage and a GPU, and that's where the Magnum I/O comes into picture. Now to make life of a developer easy, for example, any developer starts with some code. They start with GitHub, pip install this, that, and hundreds of packages and discrepancies and incompatibilities, and they spend their day in, day out in solving this problem. And this is not one-time problem. I mean, when you develop something, when n number of people develop something, that has to be coherent development. Now, one person is developing at PyTorch 11.7, another person is developing at PyTorch, let's say 2.0. Makes a lot of challenge when you merge this code, right? So we provide this everything in a form of containers. You just pull up a container, develop everything within a container, okay, commit your container and put that container into production after some optimization, obviously. We also provide on top of these containers, we provide SDKs. Now most of these containers and SDKs are free for developers, open sourced mostly. So for example, if you want to develop your own Hindi, English LLM, you will start with something called Nemo SDK. Now Nemo SDK is a neural module. It's a modular approach of developing something. Now you can do the same stuff by going to GitHub. You can write 100 line of code, still the stability will be concerned, right? And you can develop that stuff. But by just using few line of code, like 10 line of code, you can do the same stuff with the help of Nemo, which is yet open source. You can go to any layer. You can, if you have just started working on Nemo, you are just working on your laptop, you have started with a 1 billion parameter model. Let's say you want to extend that model onto your PC, which is on your desk, which is having 4 GPUs. You can just change the parameter to 4 GPUs, change number of decoder or encoder layers to n number of layers, and you will be able to scale. Same framework, same things, just change the parameter. Let's say you got one model which is purely on Hindi. You want to basically tune this model for Hindi and English. You can do that as well by doing a model fine tuning, by using just the required data and just few line of code. So it's a modular development approach that we provide, and so true for all the SDKs that we have over here. So our journey in FSI is not new. Since when we released CUDA, which is Compute Unified Device Architecture, which is a set of libraries, provides you the power to use GPU by using the lowest amount of code as possible. So when we released CUDA, a lot of people started using it for option pricing and for the HPC derivative simulations and other stuff. Then came TensorFlow, PyTorch. People started using the same GPU for fraud detection by using deep learning. Then we released something called Rapids. Rapids is a framework to accelerate your data processing and machine learning task on a GPU. A lot of companies, a lot of banks started using Rapids for faster ETLs, faster pre-processing of the data. And then people started releasing, Bloomberg has released Bloomberg GPT, which is a finance specific GPT. Now these are all the foreign customer. We do have customer in India. So in 2020 we worked with HDFC. We worked specifically accelerated their fraud detection model from 6. It takes about 6 weeks to train. So we just train it in 6 minutes. I'll come to detail of this particular use case. So that's where they could deploy this model to all the regions, and they could do the fraud detection in least amount of time. We are also working with NPCI for the longest time, but recently we have announced what we are doing with them in the AI summit that took place before 2 months. And it's a population scale development. So for example, 250 million requests are coming to your platform. Somebody is transferring money to somebody, and this buddy is transferring to 100 other people. Money get siphoned off very easily in this kind of a system. So how do you detect that within a 250 million transaction, there is a money siphoning taking place? Okay, there is some actors are basically are doing a money laundering. So that is what it's a NP hard problem, basically, N square problem, and we have conquered that problem. Now this calculation can happen in real time. And so we have the SDKs for all the needs in finance. For example, a customer comes to you and asks about some detail. Usually, someone said in the session in the track 1 that if you increase number of iterations, for each iteration you will lose 1% of customers, right? So to decrease that time and to provide the insights when the customer first hit you. So at that time, enterprise search will comes into picture. So when you have everything into a RAG workflow, when you have everything in a searchable format, you can just hit it in a natural language, and then you will be able to get the required answer within no time, and you will not lose that customer. Same comes with the customer service. The more they wait, more they get frustrated, more they write to the public platforms, right? So these can be made very fast, real time, with the help of large language model and the optimization that NVIDIA brings on the table. Another problem, anti-money laundering, KYC, transaction fraud. Typically, transaction fraud is something which is very essential, but because of the volume of transaction and the problem space, it is not done in real time. But if you don't do it real time, it has already happened. Now you are taking a countermeasure on top of that. Instead of that, if you can do it in real time, that would be much more beneficial. The third category of clients are like HPC pricing, risk, and algorithmic trading, where milliseconds count, right? If you lose that millisecond, your data is not useful anymore. So that's where also GPUs are being used by companies at large. This is what the NVIDIA software ecosystem for the finance looks like. We start with a hardware layer, which is the bottommost layer, which is not shown over here. On top of that, you deploy all the CUDA, offits, all the libraries that we have. Now you pick your path. If you are a HPC developer, if you are into option pricing and risk analysis and things, you go to the HPC way. If you have your legacy code into C, C++, you go to HPC way and you try to optimize that code. If you have your code into, for example, anti-money laundering, fraud detection, typically Python code, the middle pillar is going to help you out, where you can accelerate the data processing, you can accelerate the machine learning pipeline. And if your code is into deep learning, which is, by the way, accelerated by default, because PyTorch and TensorFlow, we already have integration into place. But still, if you want more acceleration, I would recommend to look at TensorRT and Triton Inference Server. Both can give you, many X benefit than what your base model is trained for. So for any developers, any developer out here, if you want to start small, you can start with your PC having NVIDIA GPU. You can start with a small model. You can, once you receive a good accuracy with a small test set, you can basically go to copy paste the same code onto your machine, which is having 2 to 4 GPUs, right? Machine on your desk, and you can basically make that problem even bigger. Let's say if you are still successful, you can just copy paste the code on your on-premise GPU servers. You can go ahead and copy paste the same code onto your cloud. It could be GCP, Azure, anywhere, right? What provides you that power to copy paste the same code onto any machine and provide the surety that it will run? It's CUDA, Compute Unified Device Architecture. So you put any code anywhere, starting from a small offering that we have, which is called as Jetson, which is a credit card size computer. It's like a Raspberry Pi, but with GPU. So from that device to a supercomputer, anywhere you put that card, provided the resources are enough, that code is bound to work. And that is what we provide with CUDA. Now, if you are a Python developer or a C++ developer, language support is available. If you are an academic student, they generally work on a MATLAB, support is available. If you are a HPC risk related, if you are working on HPC and risk, you will have legacy codes in C, C++. So you don't need to rewrite that code. That code can be still there. You just need to use some of the directives whereby you insert some of the line and entire code will be accelerated. And if you want still more performance, you require detail regarding the topology of your machine. For example, how GPUs are connected, how GPU are connected between nodes. And that's where the peak performance comes into picture. You write your code in native CUDA, you write your code taking the system topology into consideration. Right? So, and that's when we come to the first, hands-on experience. Taking time into consideration, what I'll do is, I'll show you how acceleration, how you can accelerate your code. Okay, and I'll share you all the notebooks and the GPU resources with you, and then you can try it out anytime. How many of you are Pandas developer, or how many of you are leading a team of developers who are using Pandas? Just, okay, 10% of people. So when you use Panda, it is using CPU as a resource, right? Here is a comparison. So if you start with a 20 CPU nodes, each with a 8 vCPUs for 200 GB of CSV data set, Spark query is going to take so much of time, like 2741 seconds. Now if you go to 100 CPU nodes, it will take 379 seconds, whereas 16 A100 is going to just take 22 seconds. If I just normalize that to 1 A100, it is going to take 352 seconds. So if you put 1 A100 for this particular use case into your machine, it is going to decrease the time from 100 CPU nodes, right? It is equivalent of providing this 100 CPU node kind of a performance. Cannot generalize this to all the use cases. We'll see shortly that it is different for all the use cases. But what is the magic that we have put over here? So we have come up with some new libraries. For example, if you have code in pandas, you use CodeEF. What is the difference? Here you are doing import pandas as PD, right? Then you are in the accelerated code, you are just import CodeEF, and then you are writing CodeEF.read CSV instead of writing PD.read CSV, and your entire code will stay the same. Similarly, for Spark, you are just importing additional library and your entire code will stay the same. If you are using scikit, your code will stay the same. Instead of importing sklearn.ensemble import random forest classifier, you are importing qml.ensemble import something, and your entire code will stay the same. Okay, and so true for the NetworkX who are using NetworkX, right? So this is what you require, just one line of a change. Obviously it requires some other line of change also, because when you are going to transfer large amount of data to GPU, it will require a GPU data transfer related lines as well. But by just doing few lines of a change, like 4 to 5 lines of a change in your entire program, you are going to get many X performance benefit. And this is all available in open source. So with this, I'll just show you what is the benefit that you receive. So I'll just go to one of the example. So here I have a simple code which is import pandas as PD and CodeEF. Okay. Then I have generated some of the synthetic data, which is 10 million rows of data, and some categories which is having column A, column B, and some categories column D. Then I'm creating two of the data frames. One is in the pandas, one is in the GPU. GPU data frame is named as GDF, and you can see the syntax is consistent. Now I have two operations. Okay, I'll just first run this code because it will take time. I'm creating two columns. First one is just addition operation for the pandas, addition operation for the GPU data from. Second operation is a group by and mean operation for pandas, and group by and mean operation for the GPU. And then I'm comparing time for both the operations. Okay, simply we can see GPU took about 0.00 second. It's normalized to 2 decimal point, whereas CPU took some extra time, so lower is better. CPU took some 0.77 seconds. Okay, whereas GPU took 0.02 seconds. Okay, so just by doing a proper import and having a GPU in your system, your entire code start running on your GPU. Second example, pandas versus CodeEF example. This is very specific example that I have taken. I have compared, so these are the import steps. After the import steps, instead of focusing on just 2-3 operations, I have compared it across multiple operations. I've used lambda operator over here, just not to rewrite the same operations again and again. So I've used the lambda as one of the operator which will execute whether it's on a GPU or a CPU, and then provide me a comparative output on how that it looks like. So forth, I'll be running all the codes because I want to take less time as possible. Similarly, in the second code, I've compared the scikit-learn performance with the QML. I've used the same format of the code. First import everything, then create a dummy data in a millions and millions of rows. Here I've taken 10 million rows again. And then you take various algorithms in as an example. For example, linear regression. Then you take PCA. Then you take any other. So I've commented some of the line because here CPU was taking too much of time. Then I've taken random forest, but you can experiment with the commented part as well. And I've taken all the other possible examples over here. So that we get a cumulative idea of how it works. So let's go to our first one, which is still executing. Let's go to the second one, which has completed the execution. So you can see the green line is a GPU, the blue line is a CPU. You get performance acceleration anywhere from 2x to 52x, 97x, right? So that is the kind of performance acceleration that you get by just doing a proper import, right? Let's see the last one, which is related to the network operation like page rank and shortest path related operators. So that's where also by just doing a proper import, you will get 34x, 16x kind of a performance. These notebooks will be available to you. I'll share these notebooks to you towards the end of this session. And let's come to the first part where I was comparing between data frame pandas and CodeEF. So here also by just doing proper imports, you get 30x, you get 741x, okay, 700x. Imagine what amount of coding that you require to get the same performance on a CPU. You will never get it. But by just doing a proper import, you are getting 700x performance. And you will be able to verify once you will have the access. So this is what it requires, just a proper import and you are able to get that performance. Now coming to the second part of it, how many of you are NumPy users? Okay. Yeah, more than pandas users. That's good. So as you are NumPy users, there's something called CuPy numeric is a complete replacement of NumPy, and which comes with the same benefit, like you do a proper import and you get many X benefits. So I'll just run one of the code, which is scaling test, and in the scaling test what I've done is, so same hypothesis. So I've just imported NumPy QNumeric, NumPy is NP, QPy numeric as CNP, okay. Generated some of the synthetic data, and then there is a measure time function. Then I've written all the operations that I want to do in NumPy and QNumeric as a lambda function, and then simply called both of the function and measured the speed up. That's it. So after doing this, I'll get a chart which I wanted to show you. This is the one. Okay, so you get a performance benefit anywhere from 0.25, which is in the case of a mean, where GPU is taking more time, right? Because it's below 1, so it's CPU is taking less time. You get 35x in the case of sum. You get a Eiffel Tower 1 not 2x on a sorting function, and you get more and more performance with all the operators. So this is by just changing the import. That's it. Is it interesting? I think you'll be able to replace most of your pandas and other operators going forward. Now coming to Indic languages, it's not that difficult as people says. It's actually very easy. So we have developed internally a Indic language experiment with us. Okay. So I'll just import a RBI document. So this particular model we have developed, NVIDIA has developed in-house. The problem is this is a proper English language which we don't use. But I wanted to show you this model because we have developed it for English language, and there are ways we can convert this model for Hindi and English language as well. So I've just imported one of the document which is very old RBI document. It's a guideline basically about what services banking should provide, about damaged currency notes and other things. So this is just a document in Hindi that I've just processed, and I'll be asking couple of questions to this particular LLM about this document. The beauty is when somebody says I've done something in Indic, generally they use translation and back translation in the backend. So when you ask query in an Indic language, they convert that particular query to English language. They fire that query to LLM, and then they do a back translation to the original language, and that consumes time, right? So instead of doing that, if you have LLM which is in Hindi, that back translation time goes away. Plus, if you design your LLM into Hindi with your own data, it is able to learn intricacies of your own data, and you will get a better performance, better accuracy than a back translated model. So this is something it gives. I'm actually very happy to see this is not yet complete, but I'm actually very happy to see that it is working out. Given the raw document out of just the RBI circular raw document, extracting from PDF will have its own error. Still, it is able to capture good output out of that. So this is something also we have developed in-house, and it's very easy. It just require 3 steps. So you require a multilingual corpus, which you can also synthetically generate. You require for a continuous pre-training, for example, if you are adopting from any of the llamas or other stuff, you require some target language specific corpus, which you can also synthetically create. We have even synthetically created the corpus while training our own model. Then you require some SFT and DPO data, which is a label data, which can be also synthetically created by doing a translation on top of the available English data. And then optionally, if you want to do RLHF, which is reinforcement learning training, you can do that. Otherwise, your accuracy is sufficient, you can stop at the step 3. There are this is very detailed step that requires. So this is just a magnification of all these 3 steps, okay, and what sub steps exist within that. So this knowledge already exists, and you can also basically create your own LLM out of that. Now coming to SQL queries, which is backbone of any banking. Like all the data, maximum of it, all the transaction data is stored in SQLs. And when it comes to getting a particular data, it requires multiple people's coordination, creating a query, getting the data back. And as it was said that you increase number of interaction with customer. At every interaction, you lose out 1% of your customers. You lose out your 1% of your hard-earned customers, right? So how can you use LLM for SQL queries? I have one simple example over here. So I've created one synthetic data about credit card related. It looks like a credit card related data where you have some entries, name, credit card holders name, and then credit card number, expiry date, and address, and everything, right? So for example, you want to write a query like get me all detail about a customer whose credit card balance is 0. Ideally, you require to write a SQL query, but here you just click on the natural query, okay, and it will give you all the results out there. You can just go and see in the debug that what it is doing. I can even go to a query like list all the customer who have almost utilized their credit limit. I have not specified any credit limit related numbers. But still, the query that it is creating is like where the balance balance and the credit limit has a difference of 100, right? So it automatically creates that query and provides you the flexibility that you can speak out in your natural language, and you can create query out of that. Now, while customer is in front of the representative, they can create such query. They can just speak out in their native languages, and query will be created. Data will be there in front of them, and while the customer is there, they will be able to serve the customer. And this is all possible. This demo was built within 1 hour, right? So this is all possible today. You can also ask, like, which customer have their credit card expiring in 2025. So based on that, you can basically start selling them a new version of the product, or you can customize this query to any kind of query, and you will have more and more insight while not touching the data, not touching SQL, not touching any single person in between. And this is how it works. So you fire an natural query, it goes to LLM. For the first time, LLM sees this particular database, what is the schema of the database, what each field corresponding, what is the information in each of the column. That is for the first query. And afterward, it just start converting your natural query into SQL, fire up the SQL onto SQL database, and give back the results to you. Right? Naturally, this is the simplest most case. You can go to LangChain, you can go to SQL connector, and you can readily get this connector connected to your LLM. Now, there can be a complex case, which is always will be the case, like your SQL databases are spread across your organizations, and many hundred people or many hundred admins are responsible for maintaining those SQL databases. So in that case, it additionally requires a router. Router is nothing but, for particular table, you describe that table well, that, this is a credit card related table. This table has so and so information. So anytime when the query comes from a LLM which is related to credit card, it will be routed to that table. If you describe another table as, this table has all the loan related data, housing loan related data, then any query comes which will be rerouted to that particular SQL. If any queries which is very complex, you can have a decomposition of the query which will go to multiple of databases, fetch out multiple knowledge bases, and then LLM will think on top of that and provides you the result out. So it just requires additional router, which is also a small language model, or can be the same model which does the routing to particular database. Then comes a new development, which is a graph RAG. So all the enterprise knowledge can be considered as a graph. Like you have some data of customer which is a central table. That customer has taken a credit card, debit card, loan. That customer has some pending dues and everything. If you connect everything, that will be a graph. Right? And everything in the world is a graph. So your text is a graph because it's connected everywhere. Your enterprise knowledge is a graph. Because see, if I'm a customer to X bank, if I go to X bank, that bank will have all the details about me. So everything can be represented into a graph. And if your LLM can query this graph, it will be able to understand much more than what what a singular LLMs which are siloed into a particular business vertical will be able to understand, right? So there's a new development that we have pioneered, which is Graph LLM. So in the Graph LLM, you provide a simple prompt. So this is for the training purpose. I'll basically skip this. I'll go to this particular part. So we had done this particular experiment with on the financial news data, US financial news data. First step is to extract the text, and this data was available in JSON, so we had extracted the text. Utilize any of your LLM for creation of text to triplet pairs. So graph is what? Graph is made up of a basic unit which is called triplets. Now entity A is connected with some relationship to entity B. So this is the basic building block of any graph, and you need to extract these relationships. Once these relationships are there, you can create a graph out of that, and you can utilize a graph database to store such a graph. So in an enterprise, there's already a graph already built because your databases are connected with a foreign key and primary key and other stuffs, right? So you already have a graph, and then you can query this graph with the help of any of your LLM plus any of the LangChain or Llama Index or whatever tool that you want to use. So I just want to provide a simple example. So this is, at this point, I have some simple sample graph already in place. I'm just querying that particular graph. So I'm starting with some of the imports, some of the boilerplate function that will convert my graph into a numeric entities. Okay. So I'm just loading up the graph. Okay, and this is what my graph looks like at the end of the day because everything is converted to numbers. Now I'm going to use LangChain and NetworkX to load that particular graph into memory, create an actual graph in memory, right? And then I'll get all the triplets in the graph. So I have triplets like, companies, IPO market, participating in is the relationship. Okay, so I have triplets like this. So I have all the triplets over here. These are basically the building blocks of your graph. And it's a very small graph, so I have about thousands of triplets. And then you can query this particular graph. So I've used NV API, which is available inside NVIDIA. I'll show you how to use this. And then you are just querying that particular graph, like, explain how natural gas pricing in Saudi Arabia could impact the US economy. And now it is going through all the triplets which is related to Saudi Arabia, US, economy and other stuff. And it is providing me a reasoning that, I don't have a real-time information, which is okay, but it provides me all the details about, how these triplets are affecting overall larger picture. It provides you the summarization. Now, if you connect your entire enterprise as a graph and if you run a LLM, you will have the explainability. You will not lose on a key points that otherwise, people might lose out. NPAs, major factor is like, people are losing out on a key information while sanctioning the loans. And they will ultimately ignore this factor, and these factors will count in. So you can search, machine don't miss generally. So you can rely on machine as a helping hand. You can use your entire enterprise database as a graph, run a LLM on top of that, and you can get best information or reasoning out of that. And this is how the entire pipeline looks like. So you have a financial document, news articles, earning calls, everything pre-processed, given into a database. Then you run a LLM on top of that. Okay. Then you create a graph database out of that, and you start querying that graph database. Summarized into a 4-point. Just take the document, pre-process it, give it to a graph database, use LLM, query it. I am not sure, any infrastructure person over here, person who manages large scale databases, machines, servers, no one? Okay. So you can also keep watch over your infrastructure also by using LLM. For example, this is how internally we do it at NVIDIA. So this is one of the application which is used for a computer vision. So that application is running, and that application is a deep stream. I'm asking a question like, what is the FPS of this particular frames per second for this particular application, right? And it provides me all the FPS for that particular application. Now I'm asking that, why this application is slow. Okay, and it will be provide me answer on top of that as well. So if your logs, your server logs, your application logs, everything is connected at one place, and if you run LLM on top of that, you can basically diagnose your entire infrastructure at one place. And this is not just, so it is providing me answer on GPU utilization, it is fluctuating between 2 to 90% because my code is not optimal. My memory utilization is very high because some other process might be consuming it. And it provides me all the answers that is related to why I'm not getting higher FPS on top of my application. This is more on the network switching side. So I'm not sure if these texts are visible there, but okay. So here the question was asked, like, in my network fabric, why there is if there is any problem or not. So this particular LLM is going to your network fabric related data. It is trying to identify all the interfaces which is having a higher packet drops. And then I'm asking more particular question regarding, give me the interfaces where there is a very high packet drops, and it will provide me more information on top of that. I'm going to also query furthermore, like, provide me more information about these interfaces as well. And it will provide me more and more information. And I can also get a diagnostic information out of that as well. So if you are an infrastructure admin and if you want to diagnose your problems very easily, this can be of your use. How that runs? You bring all your data to one place. User related data, your terminal data, your network data, your all the PowerPoint, everything at one place. Index them properly so that your LLM can read it. And then it's a simpler process, like you ask a query, pass through a router which will select particular source of the information and then pass it through LLMs. Okay, on the deep learning side, story is little more easier because we have done the integration already in PyTorch and TensorFlow. So if you have any legacy PyTorch, TensorFlow code and you want to use NVIDIA GPU's acceleration, just put that GPU in and just at device, put CUDA as the device, and entire code will start running on a GPU. Similarly, we have something called Nemo as one of the SDK, which will provide you end-to-end acceleration. Rapids is something that we have already covered, which provides you a end-to-end acceleration on data pre-processing, machine learning, and network processing. And this can work anywhere. So, for example, if you are working on laptop, if you want to try these things out, you can install it. If you are working on Azure, Google, and any cloud, basically Oracle, you can install the same stuff there. You can install it on-premise. If you want to install it on your gaming desktop, you can do that. So these things works everywhere thanks to CUDA. For trading customer as well, I mean, I'm seeing a lot of queries from the trading customer. They particularly want to use LLMs. They want to use all the new stuff which is coming in the market. But problem is their latency requirement is very, very tough to satisfy. And that's where the optimization from NVIDIA comes into picture. Because for trading customer, if you lose that millisecond, the data is of no use, right? So they are also coming to us saying that, their latency requirement is very tough to satisfy. But still, with the help of acceleration that we are bringing, you can bring data from news, social, and all the other sources, and you can basically make a quick decision on top of that. And this is what acceleration that we bring on the table when I speak about LLM acceleration. So in the RAID is something, so any developer can go to Hugging Face, can download a model and can start working on top of that, right? But if you are here on the RAID part, and if you are concluding your POC, you will not get that benefit, right? Because if you have taken any model from Hugging Face or GitHub and if you just deployed it and considering that model for a financial calculation, you will never be able to move that model to even for a alpha level testing. Because here you will be incurring cost like 20 rupees, 30 rupees per query. But you can optimize the same model by using TensorRT, LLM and other tools, and you will get 5x, 9x kind of a benefit. Same GPU, little bit higher power consumptions because we are using GPU better. We are making model lighter and same accuracy, 8.9x boost in the performance, right? And that's where you will reduce your 20 rupees per query, okay, to about 4 rupees per query or 3 rupees per query or 1 rupee per query, right? So that is the benefit that will bring on the table. So if you do consider bringing any of your deep learning use case, just consider after you do the first POC, convert that model to TensorRT LLM, and then you will realize these benefits. And TensorRT is also an open source software. Second good thing, so if you are working on A100, which is the previous to previous class of GPUs, you can just copy and paste the code onto H100 without doing anything. You will get 3.5x, 4.6x kind of a performance boost, right? So this is the benefit of CUDA, which provides you transfer your code from any generation to other generation, and then you will receive the 3.3 or 6x benefit on top of the network. Typically banking requires support, so we have come up with something called a NVIDIA Inference Microservice Platform. In the previous and previous slides, whatever I have described, you can do it by using NVIDIA's TensorRT LLM, which is available on GitHub. Okay, if you are a developer, I would really prefer you go ahead and do that. If you want ready made stuff which is well supported, has everything built in, so NVIDIA Inference Microservices comes into picture. Everything from hardware to software to the API layer, everything is supported with SLA, and it provides you best performance which is possible. Otherwise, if you are a developer, you need to install everything. If you are happy to do that, I encourage you to do that. So there are a couple of stuff that I want to share over here. First one is ngc.nvidia.com, which is a container repository. You can just go and download any container from here, any model from here. For example, if you are working on Hindi to English translator, typically it requires millions of data point labeled data for training, but you can just go to ngc.nvidia.com and then you can just take a model which is already trained. You can fine tune that model with a lesser amount of data and get the same accuracy, right, which you desire. So it's a repository for models, it's a repository for container, it's a repository for Helm chart, which requires to deploy the particular use case at scale over thousands of GPUs or something like that. So you'll get everything at one place. There's a second one is build.nvidia.com. So many developers want to experiment on stuff before they actually buy it. So here you get various APIs, like you get Llama APIs, you get you get all the other APIs over here, Mistral APIs and things. So you can take a API, you can start experimenting, build your first application, and then you can just download Mistral from Hugging Face, accelerate it to a level, and then you can basically host that particular model on your GPUs, and then you can basically replace those APIs with these APIs. You can replace these API with those APIs. So you have a complete control over model which is running in your infrastructure. You have the data which is your own data, and you have a complete control. So this will help you to basically prototype applications much faster. And then the success stories. So we have success stories with NPCI, which is, this was just presented in AI Summit, like real-time payment transaction analysis with fraud detection at population scale. 250 million transaction at least a day, real time, okay? So this is what we are talking. This is available in NVIDIA on demand. You can just go and see it. The second one is from the HDFC Bank. So they used to take about 6 hours to run a particular operation, which is for the 10 million features. It's an anomaly detection or a fraud detection use case. So from a 6 hours to 6 minutes, and that is about 60x performance benefit, allowed them to scale these particular models to multiple regions, right? So this is one of the use cases that we have. There are multiple other banks are talking about this. For example, Capital One from 26 hours to 15 minutes, which is also a data science use case on a 3 TB of data. And then there is multiple other use cases that we have over here for the FSI domain particularly. Okay, so with this we are coming to an end. This is the community that I maintain. I organize various workshops. So if you are keen to attending this workshop, just get connected. Meanwhile, I can start answering the questions. If you have any question, please raise your hand.
Thank you for this nice session. I mean, it was very informative. Question on that, I think you talked about NL to SQL, one on the infra and another on the RAG LLM stuff. Sorry, not graph RAG, what I meant. Now on this, does NVIDIA has any offering, or you are just showing use cases using LangChain and other LLMs?
Very good question actually. So NVIDIA is a platform company. We don't have any product offering or we don't have any service offering. We work in a two-way fashion. So either you have a developers, you develop on your own, and we'll help you out to make sure that you develop very optimized solution by your own. For the second way, we have ISVs like software vendors who are developing, and we can get you connected with these people. So these are the two ways we can help you out.
Thank you.
And this is the second QR code. Those who wants to do things what I've shown hands-on, you can scan this QR code, and after scanning this QR code, you will be given a Excel sheet where all the GPU resources are there. So you can choose GPU resources randomly, because if you choose only first resource everyone, you will overwrite others' work. So choose a random one, and then you will be able to do the same exercise. You can modify the examples by whatever you want to replace with, whatever model that you are using, or if you have a dummy data of your own, you can experiment with that as well. So I've provided 100 GPU slices so that you can try it out.
Thank you so much, Mr. Patel, for that amazing session. Ladies and gentlemen, let us have a huge round of applause for Mr. Patel.